and can be upfront and honest and say, actually in this application, I think this product over here that I don't represent would be better for you. That all of a sudden now you become a trusted advisor rather than a salesman.
And I often say that we have all the requirements of space, right? Because it has to go underground and send us data from miles and miles away, and it has to work. Like, failure is not an option.
We'll put on, a standard mule shoe. Ours is slightly different just for that, but it's, everybody's got one.
The top drive and the drawworks really don't care whether the electrons coming at it are from a joystick or a PLC.
The panel, what you see here on the left, which is now controlled by one of my students, is showing you actually the control of our brakes.
As of now, geothermal is a pretty small market.
If you have tortuosity, the casing will be up against the side on part of the well. There won't be any cement there. The cement will have crescent around it.
So managed pressure drilling, it's been defined as a process to precisely control the pressure profile in the wellbore.
The key is being transparent with our clients in this case. So tell them what happened. If we had a failure, tell them exactly what happened. Whether it's our fault, whether it's whatever the issue was, we need to be transparent.
But I think it's very important for everyone in the industry to know what's out there and kind of what's happening downhole as well.
I've probably worked on 40 different performance limiters in my career. If I miss any of those and the computer is raising weight on bit and I miss any of those, I have a train wreck. The computer's going in the ocean.
Here's your new colors, here's your new thing. We don't do that at all.
Here's the tattoo you need to get.
Yeah, here's the tattoo. Sorry about the last one. We used to fake that all the time.
Hello, everybody, and welcome to the show. I'm your host, David Gibson. This is the Vidor Locksmith Show, where we're interviewing people. I like it. Where we're unlocking the secrets to success one interview at a time. I've got my brain going a million miles an hour today because I'm really excited about today's episode because Dr. Robello Samuel is going to be here with us today. I have been trying for the longest to be able to get our schedules to mesh, to be able to have him come on the show and share his expertise. So if you are in the directional drilling, MWD, upstream side of the business, or even on the completion side where you're doing through tubing applications with positive displacement motors, today's episode, this is the one. You've got to pay attention. You got to be ready to be able to ask all the questions out there. So awesome. And we've got all the people already tuning in. I'm excited about this. David Reed says, it must be Friday. It absolutely is, sir. Thank you for being here. And then he says, just to breathe. So let's all take a deep breath. Enjoy the fact that we've all gained 10 pounds since Thanksgiving week. So we've also got Paul Moore tuning in, the guys from Vibration Technology. Paul, thank you for being here, sir. JP Warren, who just started doing a little bit of LinkedIn Live stuff here recently, did an expose of his elbow, which was absolutely phenomenal. I can't wait to be able to see more people starting to use LinkedIn Live as a way to be able to promote their company. Speaking of other LinkedIn Live people, we've got Matthew Hill. He's got a whole group of guys that are up there in Oklahoma that are starting to do LinkedIn Live stuff as well. So congrats to them. We got Simpson tuning in from Nigeria. Yeah, guys, let me know where you're watching from. And if this is your first time watching the show, let us know. I really appreciate any new viewers that we got coming in. Love to be able to give you guys a shout out. Freebie Friday, Mr. Nicholas Williams. Give yourself a break, brother. Checking in from Denver, Colorado. Nicholas, thank you, Nick. Not Nicholas. I just start reading stuff and don't process the fact that go by different names. Anyways, Nick, thanks for being here. Really do appreciate it. I need to be able to go back and watch your Freebie Friday. I got too busy trying to do a whole bunch of stuff this morning. And JP says, thanks, man. I was on a show. If you guys didn't get it, there's a YouTube of it, and there's the podcast from Around the Rotary. Did an interview with JP Warren. That one's out. Go check it out. It was, David Rams Wood was also on there. Like half of my clients, or half of the people on his podcast are my clients. So I've been listening to it constantly. 25 pounds since March 6th of 2020. Ooh, dang. We'll have to get you on a treadmill there, Patty. Just joking, man. Hey, enjoy it. Don't worry about it. Let's see from Tehran. Wow. Matthew Hill says, love this show. That's what I love to hear. Then we've got Graham Mitzwell. He was on the show 2-3 weeks ago, something like that. And speaking of people that are going to be on the show, next week we're going to have Graham's friend, because he's friends with everybody, John Clegg. And then the week after that, we've got Chad Hannick. Chad Hannick is one of those people. If you meet him and talk to him, you realize how smart you are not. This guy's an absolute genius. His brain is like a calculator. It's absolutely crazy. Someone from Iran, Calgary checking in, Oman checking in. Got a lot of hard rock and hot hole drilling there in Oman. Richie saying good morning. All right, guys. Let's see here. Morning all from Armin. We've got LinkedIn user. I don't know which one LinkedIn user. Usually everybody figures out that if they come across as the LinkedIn user, that they have to put that one in. I know which LinkedIn user this is. This is Scott McNeil, because he's always tuning in from UK. Our greetings from cold, damp UK. I've been slipping through these so quick. Hello from Algeria. I still have to say this. The fan base in Algeria is a strong one. And I really do appreciate everybody that's in Algeria watching. Whenever we're allowed to be able to travel, I want to go out to Algeria, go visit a rig there, go talk to some of the people, maybe do a live show from there. Even better, Neil Fletcher. Good morning from Rival. Thanks, guys, for being here. Do appreciate it. My buddy over there, Barry Lacoste. He's a great guy. Thanks for being here. Hashtag Freebie Fridays. Thanks for shout out, brother. Anytime, guys. Oscar is one of the people that I have programmed my computer so that every week, as soon as I create a show, I hit a little button and it auto invites certain people. Oscar is on that list because regardless, every week he always reshares who's coming on and he shows up and watches the show. So Oscar, I appreciate you. Thank you, sir. I truly, truly do appreciate you. We've got ID from Kazakhstan. Wow. Qatar, Oman again. We've got Dubai and my best friend right there, my Lego best friend. I didn't know Bob Godbolt likes Legos just as much as I do. So great guy. Jack Carson, fun little fact. My very first rig that I ever worked in U.S. land as an MWD hand, Jack was the lead hand on that job. Fun little fact. So, all right, guys. Thank you all for being here. This is going to be a great show. So as per normal, we are doing the minute with Fahim in just a second. Fahim is absolutely phenomenal individual. And I'm getting to the point to where I may not be promoting him on the show anymore because I'm just going to keep him for myself because nobody's hired him yet. And I am making it my job over the next 6 to 8 weeks to be able to create another product line within Gibson Reports that is able to grow enough financially to be able to bring him in full time and nobody else gets to steal him away from me. So the countdown has started. If you're a company that's watching this and you're looking for a data analyst or an AI guy, you need to start moving quick. Andrew Quinlan, thanks for joining in here, brother. Sam says hi. All right, so let me pull up I have to hit the brand button, then I have to find the video. This is your 60 seconds with Fahim.
Hi, good morning. Thanks, David. So for this week, I wanted to mention this really interesting thing that I saw. It's related to databases. So for SQL, we know that there are different flavors of SQL, right? Some companies use Postgres, a lot of them use Postgres. Then there's SQL Server, which is like a paid service. And there's Oracle's SQL. So usually what happens is if your company starts off using one of these, it's pretty hard to migrate to a different one. Like, for example, a lot of legacy oil and gas companies I've talked to, they use SQL Server because that's what they've always seen other companies use, and they're used to the interface. Even though switching to Postgres or other MySQL might give them better like advantages, performance improvements, they're not willing to do that because they have all of that code that's already written for SQL Server. So the interesting news is Amazon just announced that they're going to release this Postgres extension called Babelfish, which will basically allow Postgres to read T-SQL syntax, basically SQL Server. So like if you have anything developed in SQL Server and you want to switch to Postgres, Babelfish will now just make it super smooth, right? It's not released yet. It'll be unveiled open source to the public in 2021. Right now, it's just for Amazon to like demo and stuff, but it has been announced and it's going to be great. So anyone who's thinking of moving to Postgres or switching, it's going to be much more easier moving forward. So that's it. That's your Minute with Fahim for this week. Thank you for watching the show.
I timed it perfect this week. Did it. All right. I was excited about that. Oh, something else I'm very, very excited about. Actually, I already brought it up, but my cousin's watching today. He's my business partner. He's watching the show. Now I'm really nervous. I usually there could be 1,000 people watching, but if he's watching, that's when I get nervous. I just want to make him proud. I want to make him feel good about the company that we created. So, I'm getting all teary-eyed. Oh, this is fun. All right. So sorry, I'm getting all nervous here now. So we got a couple of people tuned in from KSA. We've already got people asking questions. Can Dr. Robello Samuel do another lecture about casing design? I wanted to bring this up because we'll get to the question. We'll ask him the question, but also today is the IADD Ironman clay shoot that's happening somewhere in the Houston area. I don't know. It's somewhere over there. I couldn't make it today. So Scott Dixon, Jim Oberkirker, the two people that are mainly in charge of that. So I know a lot of people aren't watching this right now. Maybe they'll hopefully watch over the weekend. But if you guys are out there at the clay shoot, it's for a good cause. Thank you. We appreciate you for supporting the IADD and the different things that we do there. So be sure to go check that out. The reason I'm saying this is that the IADD also hosts, Dr. Robello puts on some courses. So he's done mud motor course. He's done some drilling courses, some casing design. I'll let him explain it, but there are some amazing, amazing courses that he puts on. We used to do them in person. Now we're also doing them virtually. So be sure to pay attention to those. And if we have any that are on the schedule, we'll ask Dr. Robello here in a minute. But he does also teach courses. So all right, here we go. What is the answer? Is 42. I don't know what the question was, but okay. Excellent. Oh, everybody's talking about it. Okay. I can't keep up with the comment section and stuff comes up and then I'm out of the loop on my own show. This is great. All right, guys. One last thing, and then we're going to bring on our guest of honor today. So if you guys haven't seen it, we have this other show. It's on the YouTube channel. By the way, go subscribe to the YouTube channel, trying to get to 1,000. That's broken record nonsense. And I don't like being that kind of social media person. It's always asking for people to subscribe, but trying to hit 1,000 for one specific purpose and one specific purpose only. Once we hit it, then I'll stop asking, never do it again. But we've got this show called How It's Done. It's kind of a play on the show How It's Made, but nobody tell them that. It's about the manufacturing process of things in the oil and gas industry. If you want your show to be highlighted on it, please let me know. We are still filming season 2, and we're trying to get those done as quick as we can so we can get them all shipped out and ready to go for the next year. Here is the intro for it because I love hearing the sound of this. And then right after this, we will have our guest of honor, Dr. Robello, here on the show. Thanks, guys. All right, and here he is, Dr. Robello. Dr. Robello, thank you so much for being with us today.
Thank you, David. I hope I can keep up with your pace, the enthusiasm. So hopefully I can do a better job.
I just should get myself hyped up for this every Friday because this is like the one chance that I get to kind of like talk with other people because I know most people don't know this, but here, I'll spin it around and we'll show you guys. I got to work in an office all by myself. I can't even spin this as far as I need to. But I just work in an office by myself. I don't really get a lot of human interaction. So this is like my human interaction of the week. Everybody in the comment section and everybody live, this is it for me. So I'm getting all of my talking out like right now. So it's kind of why the energy level's so high. Well, Dr. Robello, less about me and more about you, sir. mud motors. How did this become your area of like? I know you've got areas of expertise in many areas, but how did this become such a focal point for you?
It's David. It's a long story, but I'll try.
Hey, we've got plenty of time.
Okay,
take as much as you want.
It's almost 38 years to be precise. When I joined in the oil field as a field drilling engineer, I was sent to West Germany. That time, East and West Germany. I was sent to Baker Eastman Christensen that time. So I was given special training on downhole motor. After that, I fell in love with that motor. That eventually I ended up in doing a PhD on mud motor. You may not believe that I did some work with the medical industry. So it's a long story. Then I thought, okay, I need to do more research on this tool, why this tool is more becoming prevalent, right? As I said, it was a Colt. It was coming along with all these new designs. Then I used to call as a workhorse. It became a workhorse for our industry. Now they said after rotary steerable tool, it's the end of the mud motor. Now what happens? Now still we use behind the mud motor assisted rotary steerable system. Now it has become a racehorse. It has become a powerful downhole tool that eventually changed our industry, the way in which we work. Now it has become more like a commodity tool, right? So that's in a nutshell, right? How I fell in love with this simple tool that could not be silenced in time, which I call. That's a short story. That time we have to travel through Berlin via East Germany, then go to West Germany, all these things. But the tool made it through. Now there is no barrier, right? Around the world and you saw I have written 2 books that also with the Russian authors, the co-authors. They are called the father of mud motors in Russia. So he brought Russian technology, US technology, and tried to understand. Still, I have a small presentation which I will take you through.
Excellent. Well, I'll let you go ahead and start the presentation. If there's 2 Russian individuals that get to be called the father of mud motors, then you get to be the godfather of mud motors.
I am a foot soldier. Okay, so let me take you through this slide deck. Then I think we'll discuss more on it.
And guys, if y'all have any questions as we're going through this, please start to fire them off into the comment section. And before we forget, we should ask this. Are you going to teach another, because we did get that question, I never even forgot. Please ask Dr. for another lecture about casing design. Can you do another one about casing design at some point?
Yes, there are few planned for next year. These are all basic fundamentals so that we incorporate a lot of basics so that we can expand it to the consulting phase. The next one, which is coming, real-time well engineering optimization, which will be of more interest. Now, optimization and real-time well engineering, what are the intricacies that we need to look at it? As Fred Dupre's talk about the limiters, but how the AI is driving this, hand-holding it. So I will give some information that I'm doing with the IADD, as you mentioned, at the end of this slide.
So I have to interrupt one more time because this is an absolutely amazing comment here. As a researcher, I just followed each and every international publication of yours. Topics that you worked are really fascinating. Dr. Robello, Samuel.
Yeah.
Wow.
To add to that, I just published my 205th paper on the technical side. And
205th or 250th?
No, 205.
Wow. I've done 0.
But I don't know. At this point, I'm not sure what that brings when I look back. But hope it adds value to the young engineers who are coming into this workforce. Hope I did.
Well, on behalf of everybody else, thank you so much.
Yeah.
And I'll stop interrupting. I'll let you do your thing.
Okay, so I don't want to bit more academic side, but I would like to take you through some basics. Then I will pin it at the end and funnel it a few thoughts. I call it as a workhorse. As I said, now it has become a racehorse. Always I tell the students, David, I also teach at the University of Houston and the University of Southern California as an adjunct professor. I used to take the early morning flight to LA, teach a class, and take a red-eye flight and come back to Houston. I enjoyed. Now it's all gone, right? So I'm somewhat losing that opportunities, but still I teach online. So I tell my engineers as well as the students, you might have heard the think outside the box, right? Always people will say, managers will tell, oh, you need to think outside the box. You are so boxed up. But I tell them, right? So do you need to think inside the box? First, you have to think inside the box. What is happening? What is the physics, the boundaries, fundamentals? If you don't know what is happening inside the box, there is no point in thinking outside the box because you don't know what is happening inside the box to start with, right? So you need to know the basics. That's how I started teaching these basics on mud motors, drilling optimization, tubulars, all these things. Now I'll take you through two examples. You can stop me, David, at any point. But one, let me ask, what is this figure? Maybe I will ask you, David, first. Can you tell me what is this figure?
I gotta go. Oh, oops! I messed everything up there. From what I can see, I'm gonna actually make this full screen on my side so I can.
I don't want to put you on the spot, but I usually put the students on the spot.
Like a flower, but not quite. Something odd there, and I feel like I'm going to get tricked on this one. But yeah, I'm going to just say a picture of a flower from a patent application, at least.
Yeah, at least if you narrowed it is from a patent, right? It is a fly swatter. It is a patent that has been filed for a fly swatter, right? Now, I'll take you through another one. First patent was filed in 1900 on fly swatter. Almost every, you can say approximately one patent every month, right? The latest one filed? Amazing, is it not? You know how much money we spend on filing a patent?
Yes, because I recently just did it. I know, or at least I know how much it cost me, because that one came right out of my pocket.
Yeah, see, to add to that, I have the Halliburton, not me, filed my 100th patent on downhole tools and other things, right? The thing is, why I want to put it on the context is how much money we spend, right? What is the value that we bring for this fly swatter? So that is the problem of thinking outside the box without knowing what is happening inside the box to start with, right? So now I will take you another context. So now the thing is, you have to start what is your frame of reference, right? That is the fundamental question to be asked with. Are you inside the box or are you outside the box? If you're already outside the box, there is no point in thinking outside the box because you don't know what is happening inside the box to start with. That's why I emphasize you need to know the physics, basics, boundaries, lines, and other things. Otherwise, there is no point in thinking. So the thing is now, these same guys, now they change the tune, right? Now first we have to know what is happening inside the box. So with this, all this backdrop, I wanted to take you to the next one. The guy who thought inside the box, that took him outside the box automatically. He's called Dr. Moineau. One of my admirers, researchers. You know how many patents he has filed? The first was almost 1930. He filed. No, each and every month we see a patent on mud motor. Amazing, isn't it, David? So now it's a contrast, right? A fly swatter spending $15,000, and another one filing 1930 and following 1,300 patents every month. That to change the world. Tremendous, one of the powerful innovations. You need to get a load of it. He was at the age of 16. He had an invention of a glider plane. Then eventually he was drafted for the World War I. He was flying fighter jets. He was an avid pilot also. And what he did was he saw the problem of the air breathing machines. It needs more power when they were doing the bombing runs, right? So he was working on, in one of the Monaco air shows, he first displayed the seaplane. He was a powerful innovator, he himself. Then he came, okay, I need a powerful supercharger for this air breathing machine, for helicopters and other things. Then he invented this Moineau Pump. He joined the university, he did his doctoral work. When you look at his PhD thesis, 34 pages. You may not believe, right? Now I have written 900 pages of his work, follow-up work, in 2 books. Still I have a manuscript for another 400 pages. You will, when you read through all his work, the initial work, you'll be amazed, right? That is the powerful way that the guy who thought inside, that took him outside. And so many people are following his footsteps. So that is a little panoramic backdrop of this innovation. Now we call the Moineau Pump. Is used in chemical industry, mechanical industry, and we inherited, and it is a pump, right? We use it for oil and gas pumping, which is the progressing cavity PCP pumps. When you look at, you can invert and make it as a motor, hydraulic motor. And we found it is very useful, and we use it as a downhole motor. So that is the little background, right? As I said at the start, a simple machine that could not be silenced in time. They said that's a final coffin, nail on the final on the coffin of a mud motor. Rotary steerable came. Now it has mutated in several forms, agitators and other things, right? So it is a powerful power section that we cannot forget it. Just I wanted to take you through some of the timeline it has taken. You can, the main emphasis is you can see how the progression happened. One of the things what you will see is turbo drills came. Electrical motors came, then percussion hammers came. So you will see all these things. Then the single PDM, now it is commonly called a PDM, positive displacement motor. Now it has been taken to multi-lobe motors. That's one you can see. It just, I will skip and hop through it. Now RSS with power section. So you will see the progression. Now based on this, what is going to come next? That is important, right? Our mind is wired always to think ahead and what is going to happen, right? That's where the innovators come into play. So what is the next phase? Based on when you look back 30 years, it could not be silenced, right? It will go further and it will take it to a next step. So now, if you put it on the bit side, we have not made tremendous progress. Just for reference, because I don't want to take it to a referential aberration of some of the things, but it is the one that even though we have improved materials and all of the technologies on bit, but it is the basic things still we carry forward. But there is a tremendous change on the mud motor side. Just I wanted to highlight here is Russians went towards the turbodrill side, turbines, right? They had a lot of innovations when they were close country. They started innovating on that, but they missed the boat on mud motor on the Moineau type. Then they picked up later, but still they use a lot of turbines because they have advanced. On US side, we didn't assimilate the turbines because mud motor advancement was much faster than that we can. It is more, the reliability became very stronger compared to the turbines and other mud motors. So that is the timeline, right? That gives the history, but now bits are becoming more intelligent. That will also handhold the mud motors to be more intelligent. That we have to take it beyond the dumb side of iron. So now I'm not going to teach a class or a fundamental. Just I wanted to point out some of the issues on this mud motor. I'm not going to go through a basics. It is a coupled system, complex system. It may look very simple. We call positive displacement motor, but still it has a lot of intertwined connections between mechanical system, hydraulics, and thermal options. Just wanted to highlight a few things in the way of hopping and skipping through these highlights. Then I will, at the end, conclude with a few thoughts. So just to put it in perspective, we optimize bit hydraulics. Right? So the common optimization is HSI, hydraulic horsepower per square inch, or the impact force. That is purely on hydraulics. Right? But it's a coupled system. It is the pressure drop is directly proportional to the torque and the flow rate to the RPM. Now, RPM and the torque, now they are related to weight on bit, then they are related to RPM. So it has to be a coupled system. Now, when you look at, and also you have multi-low motors. So the optimization, when we put the mud motor with the bit, is completely different. So you can see how it is changing with reference to reference to the hydraulic horsepower and the impact force. Now this has to be also related to the rate of penetration. And you can see how it is changing. It is not always the traditional approach of HSI and impact to force may not work. It is self-defeating when you start using it and think that the system is optimized when mud motor is in the system. Now you can see the ROP effect because weight on bit, the weight on bit changes the torque, then the torque and the differential pressure. So everything is coupled. That's why the optimization of using mechanical specific energy, probably some may dispute, but always you will see here. with a hydraulically coupled and mechanically integrated. So we need to think of a hydro-mechanical specific energy. Right? Now, mechanical specific energy originally proposed by Thiel. He is a mining engineer, came from mining, where they don't use hydraulics at all. Right? It is a mechanical force, RPM and weight on bit, and they try to use it. And it was brought into the oil and gas industry. Ralph Pézier promoted it. And now when you look at this, it is an axial thrust, weight thrust, and the rotational thrust, and the hydraulic thrust. Because the energy is, you take the basic definition, the total energy input into the system, and the output energy that you are, what is the one that we see is the rate of penetration, the expended work. Now, when you look at the hydraulic energy, mechanical energy, and ultimately we have to include the thermal energy, but now at this point, so now axial thrust, rotational thrust, and hydraulic thrust. So now, when you take the mechanical energy, specific energy, even the hydraulic thrust, the mechanical thrust, the contribution is very less. And sometimes when you look hydraulic input energy, it will be very high. So you can always normalize it into to find out what is the cost. Right now, the extreme case is nozzle jetting. Without any hydraulic thrust, rotation thrust, you can have a specific energy that you can penetrate. Right? That's the fundamental principle of sandblasting. So you can see here the contribution of the mud motor, that eventually you can put it all into the torque of the hydraulic torque and mechanical contribution from the hydraulic side or the mechanical side. Then the bit, say if you don't like it, take it all, then eventually you can go back and fall back to only the rotational thrust. Then you see the weight on bit also. So now, another point that I wanted to emphasize is he amazingly put the geometrical consideration into a mechanical aspect of a system that has a different aspect ratio, which we see in other the chemical industry or mechanical industry of a pump, where you can see of sludge pump, because we need to have a length as well as a reduced diameter that we can put it inside. So when you think of this, we have a number of stages, and they are not, so we take the differential pressure across the mud motor, but the differential pressure, when you dissect it, it will be different at the different stages. That is a complete different topic, but I just wanted to point out the variation of the temperature along the mud motor. You can see the bottom of the mud motor and the top of the mud motor. So the top where the fluid enters and it is doing work, then it exits. So you see the temperature is not uniform across all the stages. So that is a big problem, which you may not see in the traditional pumping system or a hydraulic motor system. So now we need to automatically adjust. Either we have to adjust the system in such a way that the temperature distribution is uniform, so that the fluid and other things do not get degraded. So now if you take this for different elastomers, right? Now, what is going to happen? There are now companies coming up with metal-to-metal stator and rotor. What is the effect? Is it going to reduce it, or is it going to increase it? So that's a complex system that we need to consider when we do that. So now, one is the time-based, the other one is different elastomers. More or less, it behaves the same, and eventually it reaches an equilibrium condition. But there will be a temperature thermal degradation as we drill faster, sliding and rotation, because it goes into alternate cooling and heating, cooling and heating. and it becomes very difficult. Right? So these are the things that they are spending more so that the power section becomes very strong. Then the other one is expansion, right? Now, when we do this elastomers and a lot of thoughts, right? So now stator, we have elastomers and even wall, all these things came up. Now, we have tried, why don't we make this a rotor as an elastomer and make the stator as solid piece or steel? Because the surface contact area may be different, and the contact points and the seal lines, the tolerance, all these things. But when you look at it in a dimensionless way, stator is the best option of putting elastomer. Now you can see the metal to metal, metal rotor, metal stator. What about the wear? When the multi-lobe motor is used, the number of seal lines is more based on the number of lobes. So obviously the contact points are more than slipping and sliding. We always think the rotor just rotates. You have to see it nutates, and also it slips and slides. It slips and rotates. When it is rotating, it is also slipping. So we have two friction. When you do a micro analysis, you have rotational friction as well as slipping friction. So these are the complex things that we see. So essentially, you have to study in a coupled manner: mechanical coupling, hydraulic, and thermal. So why I want to bring out this particular point is we see the performance characteristics of the surface. Is it the same downhole? No, completely different. When we have this temperature, dynamics, all these things associated with that, everything is completely different downhole. So I will take you through some three problems. One is the vibration. The tool is inherent to vibration. It is a source of vibration because it has a mass and it is rotating eccentrically. Whenever there is an eccentric rotation, you may have some problem at some point. So probably you may have some experience of driving some worn out tires, right? Obviously it is going to. Now the problem is it is coupled. Right, eccentricity, and it is nutating. And the single lobe motor or a two lobe motor or a 10 lobe motors, the eccentricity reduces, the mass increases, nutation changes, all these things, right? So now low lobe motors, the speed is very high, torque is high, torque is low. So when it goes on the other side, it becomes low, but it is not the way that we think the low lobe motor will induce high friction, high vibration. Not necessarily. It is the other way around. It changes. It decreases until 5, 6 lobe, 4, 5 lobes. Then it starts increasing because of the nutational change. So you will see this eccentricity. So eventually, if you now 9, 10 becomes very small, now you think of 100 and 101 lobe ratio, it will be almost concentric, right? Now we have other problems of friction. So now there are different ways to dampen this vibration. One is to attack, to find out the frequency that it is aligned with the string, whether it can induce or the operating range that we need to avoid when we have a mud motor, or we suppress. So now what happens when you put a metal to metal stator and rotor? Is it going to dampen? Is it going to increase? Or elastomers? Is it going to reduce the vibration, or it is, we have to somehow release the energy during that time, right? One option is we have to have a better model, or we put some vibration dampeners inside the elastomers. At the same time, we can extract energy out of it, or because of the expended energy can be harnessed in the form of electricity. So one is put up piezo ceramic materials like wafers. Either you embed it along with the elastomer, or you slice it inside so that you can generate it. The amount of electricity generated may not be much beneficial, but at least it will absorb energy in such a way that it gets the vibration gets damped. So you're countering the eccentricity in the form of the damping coefficients. Then comes, can we use this mud motor power section for compressible fluid? When it comes to the compressible fluid, when we start using foam or air, it is completely different, right? Now we are more focused towards incompressible fluid like mud motor and other things. But for compressible fluid, we have air liquid volume or the operating envelope. If we use the similar power section, can it operate under the same characteristics? All have to be taken into consideration. Otherwise, we'll be just putting a dumb iron and get some work and we are happy, right? That may not be always true for all the conditions. So one option is because the work done when you use a compressible fluid is not always uniform, because we are having the mass flow rate, right, instead of the volume flow rate. So now we have to adjust the power section. Now, why don't we have a power section that expands or compresses? So it is not a uniform cavity or uniform stage. The volume stage, volume per stage, or the length per stage is also going to be different, right? So that you can maintain the same amount of work as the fluid is expanding or doing work. Amazingly, Dr. Moineau studied this, and he did some work on the calculations, what are the optimal length that we need to find out, right? So initially I thought, okay, this is a good approach that I need to think of modifying the power section. Then I found he already did it in 1930 itself, right? So no surprising on that side. So you will see, but we can derive more work and expand the operational envelope when we use this compressible fluid or underbalanced drilling. That we need to consider. Now optimization it's a whole another game, right? So we have to consider why I'm bringing all these things. It is not a simple machine. It has a lot of information that we need to take into consideration when we design it. Otherwise, we'll at least learn in the learning process, but we have to learn it thoroughly. Another challenge we have is we do all the dyno test, we do all the surface tests, everything, right? But we have to think we deal with the complex system. People always tell, okay, our industry is very slow in adopting. We are not, right? We deal with a complete system. Two systems. We talk about edge system, all these things at the surface, but our edge is at the bottom, at the bit. It is driving a train with the engine going on its own, but the driver at the back of the train system, right? Now, at least the train is running on wheels, the track, but here we are blindfolded. We have two systems, right? The surface and subsurface. We know the disturbance, the input happening at the surface, and to some extent we know the output. But a downhole, we don't know the disturbance, we don't know the output, we don't know the input. How do we rationalize this? Let's say, for example, take weight on bit. We have at the same depth, the same time, one at the surface and one at the bottom. Our system is very highly complex system called high stochastic oscillatory system, with embedded with conundrums, paradoxes, non-intuitive things. How do we rationalize this system? How do we neutralize this system? So now a lot of data analytics. Now you see a lot of companies are putting memory-based monitoring system on the mud motor, so that we can understand more what is happening. Can we suppress some of these uncertainties on the modeling assumptions? So this is the problem, right? So now we do all the tests at the surface. Now, is it going to behave at the bottom the same way? No. The flow rate is different, the density is different, viscosity is different, temperature is different. How it gets degraded. We try to analyze bit wear. How do you know whether the bit is wearing out or the mud motor is wearing out? Because of the degradation of the output. Right? So these are the things that we need to consider within this coupled system. Now, then I thought, okay, I'll put an optimization. Let me run it. Meanwhile, then also I'll talk. Let me fast forward it in such a way that so one way to do is compare the theoretical optimized space, then also look at the practical point, then use it as a reference where you are actually. Now with so many limiters and all these things, but you can box it in a unit box. So everything can be boxed. So you know exactly where it is, right? So now if you are at the end, then you are touching the maximum. So now it is a cube, right? So using the same parameters, weight, RPM, and ROPs, and also normalize it. As you start rotating the mud motor, or you are in the sliding mode, or in the rotary mode, you can also find out. Then eventually you can couple to in such a way that you see how you are progressing. We talked about, I talked a lot about the tortuosities, right? How we are introducing this one, whether it is an optimized one. So we can monitor it in such a way that we can track. It is our eyes and brains are they have the perception that if I see it in a box or a unit dimensionless system, it is quick way to analyze it. So it is hand-holding the data and automatically adjusting it in such a way that it is also an energy-based approach, because I always like energy-based approach in such a way that you cannot violate some laws. Right? So at the same time, you will see the track of all these parameters and optimized parameters, which I call now opto-satisficed solution. Right now, if the theoretical model comes up with X, Y, and Z, we cannot be exactly X, Y, and Z. As long as within that uncertainty ellipse, we should be okay. As long as we are with that probability of achieving that optimized solution, it is an opto-satisficed solution. That will be very good, because we deal with a highly oscillatory system, which we don't have much understanding what is happening and along the string. Then I thought, okay, these are all the basics. Okay, so now let me take you to a different perspective. With all understanding, is there any opportunity? I have filed a lot of patents on mud motors also, but I thought maybe I should take it differently. what is the missing point he has left with, so that we can come up. He started with a geometrical principle and translated into a mechanical option. And it became a mechanical tool, right? So is there any opportunity, is there any window that I can enter, whether it is a back door or the front door, that I can find out whether he has missed any. So I thought, okay, the problem we have is 2 lobe motor, 9 lobe motor, 10 lobe motor. If you want high speed and low torque, you go low side, 5.4. Or if you want high torque, low speed, go for high torque, you go for the high 10 lobe motor or a 8 lobe motor and come up with that one, but you lose the speed. Now, if you want to have high speed, then you lose the torque. Right? Now, so you strike a balance and put it 5.4, 6, 7, or 5.6, all these things, right? But can we develop a motor that I can come up with one motor that will do all the functions? Okay, I need a 2 lobe motor, low speed, high torque, high speed, low torque, and low speed, high torque. Then I should be able to do it on my demand, whatever I need, downhole. As it is needed, I can use it. So I thought, okay, he started with a geometrical principle. I went inside the original fundamentals he started with. So I said, okay, let me start with a geometrical principle. So theoretically, whether it is a hypocycloid or epicycloid, why don't I put all these things inside? So I can put a 5-4 lobe motor. Inside, I can put a 3-4 lobe, and also 2 and 3. So essentially, geometrically, I can put the configurations one inside another. Beautifully, he translated in the horizontal section, right, in a number of stages. So I can keep the pitch also in the same configurations, maintain that. I should be able to maintain the integrity on the horizontal side also. So I did, okay, let me try. So theoretically, I should be able to do it. So I developed the concept. I did the studies and analysis. I did all the things. So now, then I did a study on the Pro-E and all these analytical tools I could achieve, right? So now, theoretically, you can see here on that motor, 2-3 inside 1-2, right? No, it's the other way around, 1-2 inside 3-2, right? So now I can go on do that, right? So now you see other problems, right? How do you connect multiple? Now I have 2 shafts. How do we connect it? Now I can leave other problems to the designers, right? You figure out how theoretically I could empirically there is an adequacy, right? Experimentally there is a relevance. So now I thought, okay, logically it is also consistent, right? So now I always check logical consistency, experimental relevance, and whether it is empirically adequate, right? So then I thought, okay, now it is a good concept. Okay, let me take it to the next step. So next step is go for funding, right? It is not that easy, right? So I did on my own, using my money from my pocket. I developed the easiest one is, let me grab the next one. So you can see on the right side, it's a vertical cross section. So I have multiple shafts coming. So now I can translate what is the purpose, right? Okay, power section I can provide, right? Now I can use it the same way for an agitator, maybe easy, right? So okay, I can modulate the speed on demand as and when needed, and I can adjust the frequency based on where it is placed, all these things. But what is the ultimate goal? So I if I connect it with multiple Willys type gears, I can translate it all the way to the bit. So the bit will rotate at different speeds, right? So the bit can rotate at different speeds because the inner lobe can rotate at high speed and the outer can rotate. Now it is a multi-lobe bit. So it is, so all these bits, you remember the history I presented, that will translate into a multi-speed bit in a single axis. So now all we are accustomed to a single bit rotating at the same axis, right? Only one speed. Now this bit can rotate at multiple speeds. It's a multi-lobe bits. Now I can, if I modulate it, the bypass flow, I can arrest in some other things. And so it will add additional speed to the system. Then I did some other calculations. So now it can also be translated into a hole opener. Now hole opener and bit can rotate at the same speed. Now this system will make it rotate at two different speeds. Hole opener can rotate at different speed and bit can rotate at different speed if I connect the shafts accordingly. Then I can modulate it and I can have a steering force. So now which will be the one that I can control the side force at the bit, and I can move the direction which I can go. So essentially, theoretically, I can eliminate all the rotary steerable and all these bend stops. I can steer it at the bit itself with without any pads or anything. Automatically I can modulate. But I will leave the designs and other parts and other details unnamed. So now then calculations, right? So now ultimately we need the speed and torque. Flow rate directly proportional to speed, pressure drop, torque, right? How much I get. Now, based on these theoretical calculations, I can achieve speed more than even a 2-lobe or a 10-lobe motor could achieve. Same torque, same case for torque. It can achieve higher than what a low lobe or a high lobe motor can achieve. It becomes a multiplier, right? We are putting more inside rather than just using outside. So now if you come to me, I will give you only one motor, right? Okay, you go and figure out according to that. Now if it is an autonomous system, automatically it will select the number of lobes and adjust based on the torque or the speed need. So that is a food for thought, David. Just wanted to pass it. And ultimately, I took it to a 3D printed view. Okay, let me take it to the next step. Okay, for my fun, since I fell in love with this mud motor, let me do it. I did a 3D printed power section. It worked very good. I could. There are some flaws which I could correct it, which was much easier to correct it. Then I did a power section of what I did it on the Pro E translated into this section. It was a very satisfying solution. But motor journey continues. That is still a topic. And still you will see, I always monitor how many patents are filed each month on mud motor, very specifically. Still people are finding it, and a lot of incremental changes. I could not find any leapfrogging change that could change the one that will take it to the next level. Then I thought maybe I should disseminate the knowledge that I have gained so that the new engineers who are coming to the industry. So, David, when I came to the industry, I was working in the rigs, on the rigs, right? So I was a master's. I had a master's in mechanical engineering. I'm a mechanical engineer. And I was working on the rigs. I see these tools, right? I used to ask the engineers, what is this jar? What is this? Can you, so you remember the old catalog, tools catalog by Gulf, 7 volumes, 6 volumes. So he said to go and read it. It was all spec, right? No details, no technical details. I didn't have the opportunity to read papers. That time it was not the way that we see, right? Then I thought after 30 years, still there was not much detail. So I wrote a book on downhole tools, 700 pages through Gulf. It's one of the best sellers. Then this specific tool, mud motor. So we thought, okay, do it. And had a good relationship with Boldenkos. Dmitry Boldenko worked as a chief researcher in Venebe, in Russia, Moscow. So they did a lot of work. So we started sharing and analyzing it, and then thought, okay, let's bring this technology to the forefront. And wrote a book, 400 pages, 500 pages, purely on designs, the intricacies. You can duplicate and tell what is happening. Then we related more on the well engineering, the practical applications as a guide for the engineers that they can look, what they need to look for it. That is the 2 books that I wrote along with Boldenkos. There is one book earlier, but this covers much more in detail and relate to the well engineering side and optimization. So this history that I have walked along with Ivory Tower people, and the journey continues. That's all, David. I'll pass it on to you. If there are any questions, I'd be happy to answer. I can teach mud motor for 2 weeks. Right? I'm teaching a class, I think more than 5 classes through IADD and several other classes, tubeless, drill string mechanics, then drilling optimization, which another one which I'm planning to do is real-time drilling engineering optimization. What are the things that we need to understand? It combines practical side as well as theoretical side. So these are some of the entry point to add. An additional footnote is it depends on, they are all very simple, low cost. I think IADD charges only $200 or less than that, and you get a book free. The book is almost $150 worth, right? So if you don't like it, always I tell, if you don't like what I'm teaching, go and sell it in Amazon, and you get back the money. So we both are even, right? So you be happy, I am also happy, right? So that's my philosophy. That's I have the passion to teach, so that's why I love drilling engineering, and I wanted to pass on to the new generation that they are going to take the baton and run, right? They are not going to just walk. They have to take it and run, right? That's the way that our industry is going. Thank you, David.
Thank you so much for everything that you shared. And I did want to ask, you were just mentioning some of the different courses that you're doing. You also gave a presentation recently for the IADC. What was that presentation about?
Yeah, that's a unified command control center. That is the new way of thinking that we have to move out of the status quo because we are under pressure. So now I presented at the SP annual conference, the shattered visage, the title is Shattered Visage, the dilemma for the petroleum engineers, right? How we need to position ourselves for the coming years. We talked a few years, the great crew change. Now the crew change has happened, right? So the new, workforce in the industry. So So that's one, that the way of thinking, the implementation, the artificial intelligence, robotics, and we are at the bifurcation point. And either we assimilate the exponential technologies or we fall flat, right? We will be like mining industry. If we take the exponential technologies, we are going to see the exponential surprise factor in the next phase of our industry. I came around 84, 83 in the industry where the downturn happened, the first bifurcation happened, major downturn. Now we are seeing another one. That's where ready for great innovation.
Well, I just want to say also, you were mentioning your 3D printing. So I've tried to 3D print bits, but some reason I missed a couple of cutter rows there on that one. But I did eventually get it right. That one's pink. So I just want to be able to show. I like putting that out. So if you've got that that file, I'd be happy to print some over here at my place as well. So we've got a little Dr. Robello mud motor design.
Okay. Yeah,
we've got a couple. Yeah. We've got some questions that are coming in about that. So this one's from Scott McNeil on LinkedIn. It doesn't show his name. He's just LinkedIn user. It might be his nickname here starting soon. How do you ensure each section gets the correct flow?
Yeah, it's that's maybe a small advertisement, but if you want to know more, you need to attend my class. But anyway, I will answer that. But the thing is, it's called the positive displacement model. That's what I start in the class. Why it is called the positive, why it is called displacement, why it is called model. Right? So that's a three intriguing words that we have to start with, because it's a positive displacement model. So we don't lose in a theoretical framework. We don't lose any volume between the cavities, but it is not feasible, right? It wears out, but eventually it maintains a good efficiency. It wears out, the tolerance, all this, the fit, everything needs to be taken into account. But also you see the seal lines, and it's also a helical seal line that we need to maintain the integrity. Otherwise, we start losing it, and you see the problems of elastomers or clunking or debonding, all these things. So eventually there are, one is the volumetric loss, the other one is the torque loss. Volumetric efficiency, that's why we calculate. But when you take the compressible fluid, air, foam and everything, it is completely different. At least we have good understanding on the incompressible fluid, which the mud and other system that we use. Otherwise, it is self-defeating to call it as a positive displacement mud model, right?
So on the next question we've got, are there any new developments in the pipeline WRT bearing packs? What does WRT stand for? I don't know, but that was a question somebody raised.
Yeah, you see now when you, let me take it to a higher level, right? Now, we talked about Moineau power section, right? Now, he didn't invent the mud motor, right? He gave the power section and how it works and everything. Then we took it forward with a lot of innovation. Now the eccentric rotation, multi-lobe motors, eccentric rotation has to be made concentric. So the one option is, why don't we take it eccentric rotation and connect the bit straight? We can fix some of the problems, so we'll have an eccentric hole. Why we need to have a circular hole? Then the question, follow-up question, right? The entry point of discussion becomes more into different questions, right? Now, okay, we need to have a circular hole, so concentric rotation. Now we need to have a CV joint. Now we have a radial thrust. Then we have the weight thrust, the weight on bit thrust, the rotational thrust, then the fluid thrust, all these things that we need to take into account. So we have to put the bearing packs. Now, bearing packs are a part of the whole mud motor system that we see. Now, Down the years, what happened is the bearing packs became very fragile, right? It started breaking. So the bearing packs segment of the companies started making much more advanced design. They were concentrating on this, taking all the loads. Then what happened? The shaft, CV joints became weak. So the CV joint manufacturers started manufacturing at a higher strength, all this thing to prevent twist off and failures. Then what happened? The power section became weak. So the power section guys, okay, now because power section is the main one that we don't want to reline it, we don't want to have debonding, all these things. Why don't we make a metal power section? We have a coating. Rotor is getting corroded or eroded, so we started coating all these things, come up with advanced system. So now eventually what happened? Now it is going back to bearing packs, then shaft. So it is a cycle, right, that is going on. But we have reached a point that now use and throw system, right? There are so many knockoffs. They just take a carbon copy of the power section, start duplicating it. What happens? You use and throw. After a few feet, it starts either failing or is not able to deliver as much as you want. Now we're talking about in hours, right? Vertical section, curve, and lateral in hours. We no more talk about in days, right? Then that whole mud motor will be a weak link in the system. It's like, okay, bit is getting stronger, motor is getting weaker. Motor is getting stronger, bit is weaker. Now, but we are talking about in hours, right? So eventually it is a cycle that goes on between the power section, bearing section, shaft, and power sections and the CV joints.
So which one do you think is is prime for revolution, for somebody to be able to come out with something, for the next patent to be issued? What do you think is going to be the component in there that could potentially really change the industry?
Yeah, I'll answer it, David, in a broader perspective. Right now, I'm not here to justify that mud motor is another 100 years, but it is not going to go away. But the thing is, when you look at, we started drilling vertical holes in 1980s. Then we started punching holes. Then what happened? The translation happened. Then we started introducing a lot of directional tools, then directional wells. Then what happened? We started drilling extended reach, high contact reservoir wells and horizontal wells. Now what we are doing is just literally punching horizontal holes, right? That's a prime time for the bifurcation. So now the tools are driving. So now next is, it is going to become more intelligent. And to the context for the text which I said is started with the directional tools, mud motor, rotary steerable. What is the next one beyond rotary steerable? Rotary steerable is not the end of our directional tool, right? It may, now eventually it will be taken out, right? It will be maybe more at the bit and more intelligent, so that we have we reach at the actual edge rather than at the edge of the rig, right? The edge we talk about is a misnomer. Our edge is at the bottom. That eventually the brain will be on the bit. That will become an integrated tool, which we may not call it as a bit. It may be a different tool that eventually functions all in one.
Fair enough. All right, so then we got some questions. I know we covered this just a little bit during your presentation, but what would be the advantage of a metal-to-metal mud motor? Salim, thanks for the question.
Advantage, practically, my view, it may not work, right? Because the basic question to ask is metal to metal or metal to rubber, right? So we would have gone with a metal to metal tires, right, in the cars, right? You don't need to change it. Can you convince me? Yeah, okay, now I don't have a rubber because after 50,000, it is wearing out, right? That of course, the road may be also wearing out, but it is not problematic. We change the tires. You go, okay, why don't we put a metal which can withstand for a million miles, right? It's because it has other issues also. Damping, which I covered, then also wear, and the fit and tolerance, the expansion. It is a coupled system. Once it starts leaking, that's it, right? It will go straight in the pumping mode, right? It will be no more mud motor. It's I cover, right? When the mud motor goes into the pumping mode, it can go also into the pumping mode, which a lot of people don't know. Right? So these are, I think, going back to the question, it is a fundamental problem that to be addressed with when we have a metal stator. If you say a metal rubber rotor instead of a metal stator and a rubber rotor, that I think may be more convincing, but eventually you will see that will wear out much faster than the stator. I have also given the study, which you will see practically as well as theoretically.
So we've got a kind of a technical question here. Brian's a very sharp guy. He says, how much more weight on bit and RPM can be applied to a straight motor with RSS over the same load configuration for a steerable PDM? I'm glad he's not asking me that.
Yeah, it's that's one that you need to find out. The optimization which I showed on the video, that it does it. Now we are talking about a standalone mud motor, right? When it comes to the rotary steerable and the power section that is above, that has to be seen with a coupled system. Now there are software available that will take into account. Now comparing to the straight mud motor and the deviated the straight hole and the deviated hole and horizontal hole, it completely changes. So the envelope completely changes. Probably I think I can give more detailed answer whoever asked, or I can send a detailed explanation of with the theoretical underpinning.
Well, I'll get you guys in touch with each other. I do have to give a quick one here. Halal says the all metal to metal is the future drive system for high temperature, high pressure, hard rock drilling, longer runs. I know that he's working in Oman. We've met up before. He's a great guy. So I know that he's doing a lot of metal to metal motor stuff there in Oman. So a lot of questions are coming in about, metal to metal motor, the end of stalling out. I don't know if you want to.
Yeah. It's. I think we are now talking about a different area of the use, right? The high pressure, high temperature. When it comes, the elastomere getting degrading, the temperature, debonding effects. All these things are different. That's why they go for metal to metal. But there are the efficiency draw is much faster. Now, when you look at these mud motors, there are elastomere failures due to the interaction from the wells nearby, which are producing, because the temperature is cycling there, right? That is also causing some effect. Unless you're drilling very fast, the effect will be still in the transient stage. It may not have reached a point that it will affect. But in the high temperature wells, that is one of the reasons they go for it, and the coatings are different to withstand all these things. But ultimately, the problem is overall degradation of the efficiency, not only on the mechanical efficiency but also on the volumetric efficiency. So now these are all tried: hydraulic efficiency, volumetric efficiency, and the mechanical efficiency. So that goes into, unless they have there are now a few companies in Norway, one company is manufacturing with a highly coated metal to metal mud motors. That is a very small niche market that we need to take into account. I covered in that book very little, but it is not the point of complete reference that we need to address.
So kind of asked this question a little bit earlier, but since somebody from the audience is asking, I want to put it out there. What will be the weakest component in the mud motor that will limit 100% power output?
The weakest component, now it is like a question asking, you have a heart and arteries and other things. Now, which is the weakest component? Should I say heart or the weakest component arteries? So it is the power section. The analogy is the power section is the heart, and the other plumbings are. So we went through the cycle of getting one after another CV joint, bearing pads, and minute options. Then we have this rotary and then nozzling the rotor, all these things. But ultimately, I call the power section, because the power section has to be strong enough so that it can withstand without any leakage, without any degradation of the seal lines and the elastomers. Now, overall, when you look at the weakest link is the elastomer, right? Mechanically, the stiffness is very low, but we have improved a lot, right? That's we try to make that stronger. That's where now they are concentrating. Then you can see the even wall layers, all these things came up. That improved the efficiency of the mud motor. But still, some sort of then the other one is the design, right? You need to have a very good design. A lot of good companies in US, they make very accurate. It is not just you copy, take a photo of that configuration and translate it in a machine. CNC machine doesn't work because it has very accurate. When you look at the tolerance and other things, they are very important. And even the lobes, lobe configuration. Otherwise, we create a jump in that. They minimize the slipping action when the motor rolls. So all these things are important rather than just branding a particular component. Then I will be saying, okay, I have a good heart, but my there is a small palpitation, right? Then.
So I'll go on to. We got a couple more questions that keep coming in. So guys, please keep asking questions. Blah, 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 whatever. One word at a time. Everybody's been telling me this from earlier. Okay, so Armin says, Armin, first of all, thanks for watching the show, brother. What are your thoughts on tapered power sections?
David, could you come back? Paper?
Do what?
What is the question? Could you repeat?
What are your thoughts on tapered power sections?
I don't.
So like a tapered design where.
Oh, tapered. Oh, okay. Oh, I'm sorry. Oh, I was somewhat embedded on the elastomer. Yeah, it's that is I have emphasized because you see the pressure drop is not uniform. So we take the differential pressure right across the mud motor. Say for example 500 psi or 1000 psi or whatever. So if we have 10, say 500 psi, 10 stages, so we take 50 psi per stage, right? So it is not exactly. So you will see it starts the same way I have presented on the temperature. The temperature is very low with reference to time as well as for different elastomers. And it increases at the end of the power section because it does more work. The same way, the pressure drop, when you dissect it, it will be more at the end of the one. Put the strain gauges and all these things you can measure clearly, and you will see very less. Now, one is we have uniform elastomeric section. Do we need that? Do we need the same thickness at the top? Because more work is done at the bottom. How do we counter this variation of temperature? Of course, the hydraulic loss across this mud motor is less, but the pressure drop, which is eventually on the torque, is important, how we translate. So are we giving enough load uniformly across the rotor section? No, it is not. So, so the tapered section is a good option, which I wanted to do as the next phase of a solid, this 3D printing, but I didn't have the opportunity, and I don't want to spend money, which is also not that easy. David can vouch for it. But the thing is, that will be more of importance to the compressible fluid, because the expansion takes place, right? In each cavity is not uniform. Here, at least, we don't have that difference. When it goes to the compressible fluid, the expansion is going to be different. So that is the best option. We can balance it. Essentially, it is when you have multiple pistons, we have load balancing, right? The same way we need to do. When you consider these are all each stages, it is we need to balance the load in such a way that it will be one. And interestingly, Moineau presented it. That is the way that we need to go. But the problem is, how do you manufacture that one? It is very complex, right? You have to have a. It is not with all this technology now we can do it, but it has to be tried.
All right, so we've got let me see. I had to scroll back here to be able to find it. So Oscar, once again, one of the great people, continue to keep watching the show. There are some formations in which the interbeds are the rule. Is there any dampening mechanism in order to reduce micro stalls of mud motors?
Yeah, thank you, Oscar. That's a good question and great contribution for David. That is the one that I deal with on the micro stalling, and how the one way to, when it happens, see now the traditional approach is when the stall happens, you lift, reduce the RPM or reduce the load so that it doesn't damage, right? By the time sometimes it get damaged, you have to pull on. So why don't we make it automatically? Because we have the power, fluid power at the bottom, right? That is an advantage, right? That we can use it to bypass automatically. When you look at when they put the nozzle on the rotor, it is different, right? We don't see the stalling because automatically the pressure balances, and you may end up in having micro stalling, which may not be noticeable at the top completely at all. So one option is to bypass. I did some studies which are completely different, which can automatically takes care of the stalling, not even the micro stalling, big stalling also. Then it can be used through bypassing flow, but to some extent, right? Otherwise, it may damage if the pressure is not balanced. It will damage the elastomer.
So we got another one here. It says, thank you for the presentation and sharing your knowledge with us. What are your thoughts on even wall motors? Can they perform better than standard power sections in high temperature, high pressure environments? 0.4, 0.5 rev per gallon, 1.2, 2-mile laterals, 8.5-inch hole. Give us some technical specs to go off of.
Yeah, it is a two-part question, right? Whether the even wall is better than the high pressure, high temperature, right? So that is now when coupled with the high pressure, high temperature. So this is not just a mud pump that we can do a theoretical analysis, all these things. These are all coupled. That's why I was mentioning hydraulically, mechanically, and thermally coupled. Now, even walls, always whenever there is something comes up, I go to the board and start deriving equations, try to reduce the assumptions, come out what is telling, right? The even wall definitely has improved, and also it will improve the efficiency based on various factors. Now comes to the high pressure, high temperature, and high pressure. Now there are two things. Now if we want to make it more, take only high pressure. Now high pressure, now how much differential pressure you are applying is also important, right? Now the pressure has effect, the inside that has effect. That will also increase the tolerance, and also it will create additional problems during the seal line. Now temperature has other effects, right? The expansion of the just an example, in the Russia it is the other way around, very cold, right? In Arctic, when they start using it, they have to run steam through the power section in order to make it at the particular point for performance. So now the same thing, now we are going to the other way around with the high temperature. Now there is now the distribution is from inside the fluid to the left side is rotor, the right side it goes to the small section of the elastomer, then it goes to the metal seal, then it goes to the annulus, then the formation, right? So now elastomer is that's why they go for the metal seal, of course, right? The metal stator. So now the elastomer is now becoming very weak, then it loses the tolerance, it loses the fit, then it loses the integrity of the seal line. Multi-lobe motor, then it provides a small cavity, it provides an opportunity to enter. Then once it starts entering through the seal line, then you lose the efficiency. So it is a complex problem that you have to integrate with a thermal simulator, transient simulator to model it, but it can be easily understood how the performance, and ultimately we have to monitor, right, how it is performing. That's how I developed this optimization cube, that we can see whether it includes temperature, pressure, everything. Right?
All right, I just have to put this out there. Jay's over here flaunting his wells to be sold again, so everybody just see that. I'm gonna have to talk to him after the show, sir. All right, guys. So I've got one more question myself, and then one more here we'll take from the audience. So Romero says, is there a particular bit design for a mud motor when looking for improving ROP?
That's a very generic question. It depends on a lot of things, right? Now, you can have the best of the best in the world, and your mud motor is like without one tire. Eccentrically rotating, that will spoil the whole thing, right? But that's a very generic question, right? So now, when you are building at a particular angle, it is different, right? When it is at a lower angle, it is different than it is on a lateral section, it is different. So it is all other things to be taken into consideration, right?
All right, so last question from me. We'll let you go. And everybody that's still been watching, thank you guys so much. If you would, please tag a friend, share this with your other friends and colleagues so that they get to see this amazing content that we're putting out there. So Dr. Robello, last question. So when I was working with my previous company, we had a at-bit tool that was able to measure high frequency RPMs. And what we found at one point in time when we were looking at the differential pressure and RPMs, that when you plot it out and we just scatter plot it, we'd have like two different kind of clouds of data. And what we essentially were able to put that to is that every time the MWD tool, it was a positive pulse MWD tool, that every time it pulsed, and it was doing a standard like tensor style MWD tool, not a siren wave pulse, but just a standard, 1 second on, 1 second off kind of pulse, that it was actually changing the RPM of the mud motor, and that you could see the drop as it was going along, right? As the drilling was taking place. How big of effect do you think that would actually make to the mud motor system as a whole, to where it is deaccelerating and reaccelerating and deaccelerating and reaccelerating, like having those consistent changes just from the power that's essentially the power and the mud flow that's being provided?
Yeah, it's see, when you think, that's a good question. A lot of paradoxes we have seen. There's an example, we put measurement, vibration measurement devices above and below the mud motor to see how the mud motor is contributing. Sometimes we see same BHA, we see the other way around, right? It is not it is, so it has a lot of other interconnected things. One is the MWD, which because since it is very close, that creates additional pressure waves, because we think always the flow rate is directly proportional to RPM and the pressure drop related to torque, but it is not. When you look at the performance chart on the dyno test, you will see it is also going down. Now, when you plot it the same way that you will do at the surface, when you modulate the flow, you will see that oscillation, right? That's even though there is few second cycling, but you will see that. But you won't see too much oscillation of the RPM. Actually, I'm presenting a paper on motor dynamics on the IADC conference. Unfortunately, I have to withdraw, but I will be presenting in the annual SP conference how the RPM, the pressure pulses that you can send or you can create will create additional oscillation at the downhole. And it can be the other way around also, right? It can be an influencing factor from the bottom, which are connected to the torque, weight on bit and the torque, which is essentially the delta P. Then it is also connected to the flow rate, and it is going at that. When you have this may happen when there is no nozzle on the rotor. When you see on the, I don't know whether you have seen same behavior. You may not see the same behavior when you have a nozzle on the rotor. You may not be seeing that. That is a little different than what you see, right? If you have the data, if you could go back and see when you have some information, nozzle the rotor and see whether you will see that one. You may not. I bet you may not see that.
Well, thank you so much for your response, sir, and thank you so much for your time today, Doctor. I really, really do appreciate it. Any last words that you want to give to everybody out there still watching?
Yeah, one thought, right? Always I end up with this one simple question, right? It is a very good industry. How you respond and find out is easy to find out from your children. Okay, if you are so attracted, I always tell my students and engineers, if stick with me, you will become a drilling engineer. Whether you like it or not, by default, you will become a drilling engineer. Right? So now the question is, I ask the audience, how many of you, if you like drilling and you talk about drilling, all these things, how many of your children are drilling engineers? I talked in a IADC SP, I think, award ceremony, and asked, none of them could, it was the IADC conference, none of them could raise their hands. You know, I have two children, a son and a daughter. Both are drilling engineers. Both are working for operators. Both are deep water engineers. I have a son. He is also a deep water drilling engineer. He just got promoted. And the another one is deep water drilling engineer, working for Gulf of Mexico. So I don't know, by deep, I never told them to become drilling engineers nor a petroleum engineer. But I don't know, my wife always says, babe, because they are sticking with me. That's why they have become drilling engineers. And I told my wife, you don't want to be a drilling engineer. You stick with me and I will take you all over the world. But now we are stuck in the house, almost in the same room, right? So, but I just wanted to pass on. It is a good industry. We need the drilling engineers, very good industry, but you have to position yourself, right? The future is very tough. It is going to change, but you have to position yourself that you are indispensable. Thank you. That's a last word that I wanted to pass it on. Thank you, David, once again. Privileged to sit on your show. Happy to be there.
Well, thank you so much. I do appreciate it. We got a couple of guys coming in here towards the end. We even had Jay says he's had 4 children, all boys, and they're all geologists just like him. Reggie says, David Gibson, Dr. Samuel Robello. Samuel, thank you. Another great show. I
want that answer for 100% of their children. If they have 5 children, all have to be drilling engineer. If they have 2, they have to be drilling engineers. Not 1, right? So,
well,
okay.
We'll see what happens with my twins. My son is 3rd generation reaping. We did it the hard way to the top. LOL. Well, Patty, thanks guys for joining in. We do appreciate it. Keep clicking wrong buttons here. Salim says, thank you, Dr. Robello and Dave Gibson. That's me. Yes. Guys, thank you all so much. We do appreciate it. So next week, we've got John Clegg coming on talking about innovation. And then the week after that, we've got Chad Hannock in the month of January, because that'll be it for December, because I'm going to take some time off just like everybody else should. In the month of January, we've got lined up Cathedral Energy Services is going to come on. They got one of their guys that are going to come on and talk about EM tools. So EM telemetry. The week after that, we've got the guys from Rhyme Energy Services or Rhyme Downhole. I can't remember. They've got 2 different names there. So we've got Manoj Gopalan and BJ that are coming on. And then the week after that, we've got a VP from Baker Hughes that's going to come on and talk about remote drilling operations, things of that nature. Guys, thank you all so much for supporting the show. Really, 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 really do appreciate it. Once again, the show wouldn't be what it is without our amazing guests and our amazing fans. So thank you all. Dr. Bell, go have yourself a wonderful day, sir. We will definitely have to do something like this again. Maybe we can do casing design or, I don't know, one of the other 100 topics that you are an expert in and can share with us. So as always, guys, see if I get it clued up here. Close for life. There it is. As always, guys, know your industry.